Okay, so today we're going over some of the problems that are in chapter 18, which is pediatric dosage calculations. So the big thing with this is, one, I've already been asked by a couple of students to do questions number 8 and number 10, so I'm going to go ahead and do those, and because these have kind of several steps to them, but ultimately we're doing the basic kind of things as far as dimensional analysis goes, and just adding in the weight of our patient, and then figuring out two different methods. First is going to be in milliliters per hour, the other in drops per minute. So still go through here and write all of your information down. So my first bit of information is the recommended dosage of gentamicin for a child is 6 milligrams per kilogram per day. Per kilogram per day. And they want that in 2 equal doses. So ultimately, to get our per dose, we're going to divide that by 2. The child's weight is 44 pounds. And the tubing drop factor is 60 drops per milliliter. And then the medication is supplied in 60 milligrams in 100 milliliters to infuse over 90 minutes. So the first question asks us, as far as A, B, C, and D, what is the child's weight in kilograms? So A is how many kilograms? Now, if you need to set this up in dimensional analysis, information-wise, again, we're solving for kilograms. So how many kilograms? So we know with that, we start out with kilograms on top. So we know 1 kilogram is equivalent to 2.2 pounds. And then this kid weighs 44 pounds over 1. And ultimately, that's going to give you 44 divided by 2.2. So ultimately, what I do is I always divide, without doing this step, just divide my weight in pounds, divide by 2.2. And that gives us a weight of 44 divided by 2.2 gives us 20 kilograms. So our first answer in how many kilograms is 20. And then the next question asks us, calculate the dose for this child. So we want to know the dose. So ultimately, we go back up to our information. We've already used this, so we don't need that anymore, nor do we need this. Whoops, we need this. Sorry. But we're going to put our 20 kilograms up here to figure how many milligrams per kilogram per day that this child should receive. So I'm going to put 20 here. So we have 6 milligrams times 20 kilograms would give us how many milligrams per day. And then to figure that one out, we would then, or to figure out our per dose, we would divide that number by 2. So 6 times 20 gives us 120 milligrams per day. And if we divide that, that gives us, by 2, that gives us 60 milligrams per dose. So that would be then the answer to our second part of our question here. So we have 20 kilograms, and for this child with this weight and giving 6 milligrams per kilogram, we want to do 60 milligrams per dose. So then for C, we want to solve for how many milliliters per hour. So we go back to our dimensional analysis and set up our problem. We have milliliters, since that is our first part. We want to put milliliters in here. Now, you'll notice that this is in time, and you have to find our information that is also in time to figure out this part of the question. So, because we do have 2 things that have milliliters in them. We have our 60 drops per milliliter, and then we have our 60 milligrams in 100 milliliters, and it goes over 90 minutes. So this is the information for our milliliters per hour that we will need to use. So with that being said, we have 100 milliliters because this 60 milligrams is in this, okay? Then we put that over 90 minutes. And that's not where we need to end up. So if this is minutes, this has to be minutes. And we're going to convert it to hours. So then we put in our known variable of 60 minutes is equivalent to 1 hour. So then we do 100 times 60. And that gives us 6,000 over 90. Gives 90 times 1, about 90. And that gives us 66.6 repeating. And I know it says do not round our doses, but for this one, go ahead and round it to the whole number, and that would be 67 milliliters per hour. So that would be our answer to the C portion of that question. And then we have our D portion. And our D portion is calculate the drops per minute. So that's what we're solving for. So with this one, we have, since we're starting out with drops, we're going to start out with drops on top. And we find our other bit of information. So this one, which is 60 drops per milliliter. And if this is milliliters, we have to have milliliters here. And our other bit of information that we have with milliliters in it is the 100 milliliters. Whoops, not milliliters. 100 milliliters over. Sorry about that. Didn't mean to put the milliliters there. So 100 milliliters again over 90 minutes. And is that where we need to stop? Yes, so we don't go any further. So we do 60 times 100. And that gives us 6,000 over 90. And what do you know? It's the same math up here. So we also will have 67 drops per minute. Would be then our answer to number 8D.